Hey guys, welcome to my presentation. My name is Mokhonga Khomosego and my project is a sun tracking solar automated cool air conditioning system. The problem is that corpses get rotten at mortuaries due to load shedding, and this disables lots of families not to say their final goodbyes to their loved ones. This project solves these problems, and it makes it possible for families to clearly identify and bury their loved ones with dignity. And it also eliminates problems such as air pollution, and it also eliminates many infections associated with decomposition. The servo motor will be connected to the two LDRs and to the solar panel for sun tracking, and also to power up the battery for the system to function. The LCD will display the temperature measured by the DHT11 and the number of people counted by the IR sensor. When load shedding occurs, the fan will go on and the orange LED will also go on. The Peltier module will be used to get low temperatures. IR sensor will count how many people have entered the room. Using the touch sensor, when someone enters the room, the buzzer will go on and the blue LED will also go on. The ESP8266 will record data over the cloud connection. Data of the two LDRs, the DHT11 and the touch sensor. Now let's go to the breadboarding. We have the 9-volt battery. The LCD, the DHT11. We have the ESP8266. We have the Peltier module. We have the servo motor, the fan. We have the resistors, the LEDs, the 1000 microfarad capacitor. We have the buzzer. We have the two LDRs and the solar panel. We have the touch sensor. We have the infrared sensor. This is the relay module. And we have the Arduino connected to the laptop. Now the operation. So the relay is the switching component for the two LEDs and is powered by the battery. When someone enters the room, when someone touches the door, the touch sensor is activated, the buzzer should go on and the blue LED should go on. Someone enters. The buzzer is on and the blue LED is on. When someone enters the room, the IR sensor will count how many people are entering the room and it will display on the LCD. The first person is entering the room, the second person, the third person, and the fourth person. So when load shedding occurs, the temperature will likely go up. So the DHT11 is measuring the temperature. Immediately when it reaches 20 degrees, the fan should go on and the orange LED should also go on. Now it's at 20. The fan is on and the orange LED is also on. The Peltier module will gradually decrease the temperatures. The reason for the knife is that the knife is acting as a metal plate for the Peltier module, because the Peltier module produces both the high temperatures and the low temperatures. In this case, we need the low temperatures. The temperature is decreasing gradually. Now let's go to the LDR, the two LDRs. When the sun is this side of the panel, the motor will gradually rotate in the direction of the sun. As you can see, the motor is gradually rotating. And then when the sun is this side of the panel, the motor that it will rotate gradually to the direction of the sun. Now the ESP is connected to the cloud. As you can see, this was created just 4 minutes ago. I have created 4 fields, which is the DHT11, the 2 LDRs, and the touch sensor. Now let's go to the DHT11. When I touch the DHT11, temperature should go up, and it should also go up on the cloud. You can see. Should go up here. Yes. Now the touch sensor. When I touch the touch sensor, this also should go up on the cloud. The graph should go up on the cloud. Then going to the two LDRs. The LDR should also go up. Yes, thank you.